to talk about uniform data and how to randomly generate uniform data. So let's type in our unit. That's the one we're going to be using the most. All right, so this is the uniform distribution. So much like the R, much like the normal distribution, you're always going to have these prefixes of D, P, Q, R. That's true for the normal distribution. That's true for the student's T distribution. So D always stands for density. That's our density function. P is our probability. Q would be the opposite of probability. So if we gave it a probability, it'd spit out the data value that would have that probability. And our Unif randomly generates uniform data. So let's go ahead and do that. So I want to randomly generate some uniform data. N is going to be the number of data pieces that I want. And I define like a minimum and a maximum. So let's say I want our Unif, I want 100 pieces of data that have a minimum of 2 and a maximum of 13. Note, I could type in min equals, I could type in max equals, but I don't have to. All right, so let's go ahead and plot this data using a histogram, because if I use plot, I'll show you real quick. Well, first I should probably define this data set. Let's call it U1 because it's uniform. Get it? Creativity here, guys. Okay, let's plot U1. And this is going to look like a hot mess because plot means scatter plot. So what it's doing is it's plotting like each pieces of data index, so be it data 1 through 100 with its value. And I don't want this. I need a histogram, or I need a table, I need something. So we're going to do histogram of U1. And just as a little refresher, like I could go ahead and label my main title. So it could be 100 pieces of uniform, random uniform data. And I want to label my X value, my Y value will be labeled. So let's label our X value. A value between 2 and 13. Note I made a mistake. I did not put this in parentheses. I also didn't spell value right. If you've been here a while, you know I'm not a good speller. Oh, look at this, 100 pieces of uniform data. This doesn't look really uniform. So let's go back to our Unif and let's think about this density function. Let's see if I can make a curve on this histogram. I haven't tried this before. If this doesn't work, sorry. So I'm going to do the curve. Instead of D norm, it's going to be D uniform of X with my min of 2 and my max of 13. And then I've got to make add equal true and give it a color. That should be a capital true. Add equals true, color equals pink, because I'm in charge. Okay, now that didn't work. Why didn't that work? Well, remember from our R norm video that this would have to be a probability distribution. So I need to do probability equals true or frequency equals false. Again, either of those would work. And then pink's not in my parameters, so we'll do red. All right, so there, oh, it should be call, not olive color, color. I can do pink. Don't be afraid to break stuff. All right, so let's run this. So now I have a pink line. This line is going to be the straight line where my uniform distribution would have been, right? So it probably lines up with the mean of this data set, which I could find out if I wanted to. The mean of this data set is going to be mean x, not x1, u1. My mean is 8.12 and my standard deviation is 2.9. Not bad. All right, what if I make another data set? What if I make U2, okay band, our uniform, 100 pieces of data, but this time I want a minimum of 0. And a maximum of 1. So this is a pretty tight data set, and I can go ahead and graph it if I want. Histogram U2. I ran it. We'll run it again. What did I do wrong here? That's not running because it didn't have an equal sign. Learn how to troubleshoot. There we go. Here's my histogram of U2. Absolutely beautiful. Notice it's not like super uniformly distributed. If I was to say make even a bigger data set, so let's do U3. How big do I want to make this? Well, I don't want it to run too slow. So what about like 10,000? Actually, that might be a little big, but we'll do it anyway for science. I don't need commas. Min is 0. Well, max is 1. Those are our default settings. So let's plot U3 right now. By plot, I mean make a histogram because plot would just be a hot mess like I showed us earlier. See, it's starting to get more and more normally distributed. Like the more zeros I put into it, I might regret this. Oh, it ran it really fast. See, it gets more and more uniformly distributed the bigger the set gets, right? That's an example of the central limit theorem. You just want really big numbers. The bigger your data set, the more true to the mean it will be. I want you to know there are things you can do with your data set. So like, for example, I could add them. So here's U1 plus U2. Note the mean of U1 was 8 and the mean of U2 was like a half. So any guesses on what the mean of U1 plus U2 will be? Any thoughts? Yeah, it's just gonna be them both added together. I could also divide, so I could take U1 divided by U2. Okay, I could even plot that data if I wanted, but not with a plot, with a histogram, right? Oh, interesting. So U1 had a min of 2 and a max of 13, and then we were dividing it by much smaller numbers. Note there were definitely some outliers, right? This is definitely not a normal distribution. What if I was to multiply them together? What might that look like? And keeping track of like how like the means change and the standard deviations is kind of a fun thing too. So that's definitely very, very skewed. What if I did this a couple times? What if I like squared this? Like, is there any way it might approach being normal? No, it's definitely just going to keep getting closer and closer to between 0 and 20. Interesting. We could also subtract. I could also take something times itself. So I could take like U1 times U1. Let's see what that looks like. So U1 squared essentially. Make sure you spell histogram right, and then it'll work for you. Okay. If I multiply by U1 again, I wonder how many times I'd have to take for it to start to get kind of normal. Again, this is just me playing around, y'all. So that's what I wanted to show you. I wanted to show you guys how to use the R uniform um, function, how to plot a curve using Unif, the same thing because you want to use the density function, and the fact that when you define data sets, be they of uniform data or of normal data, we can add, multiply, subtract, graph, do all the things.